Welcome to the mysteries of the cosmos. The ultimate fate of the universe has been a subject of fascination and study since the dawn of modern cosmology. As our understanding of the cosmos has evolved, so have our theories about its long-term future. For a long time, scientists considered two possible scenarios for the fate of the universe: eternal expansion or the Big Collapse. The eternal expansion scenario suggests that the universe will continue to grow indefinitely, dissolving into a vast ocean of space. On the other hand, the Big Collapse proposes that gravity will eventually slow the expansion, causing the universe to contract in on itself. The key to determining the fate of the universe lies in understanding the relationship between its expansion and its matter and energy content. If the density of the universe exceeds a critical value, gravity could eventually stop the expansion and cause a collapse. This scenario, known as a closed universe, would culminate in a big crunch, the reverse of the Big Bang. In contrast, if the density is less than the critical value, the expansion would continue forever, leading to an open universe. A third scenario, the flat universe, represents a delicate balance where expansion slows but never stops completely. For decades, astronomers worked to measure the density of the universe and determine which of these scenarios was most likely. However, in 1998, a surprising observation dramatically changed our understanding of cosmic destiny. Two teams of astronomers studying distant supernovae discovered that the expansion of the universe is accelerating. This revolutionary discovery implied the existence of a mysterious force that counteracts the gravitational attraction of matter. This force, called dark energy, makes up about 68% of the energy content of the universe. The exact nature of dark energy remains one of the greatest mysteries of modern physics. One possibility is that it is an intrinsic property of empty space, similar to the cosmological constant proposed by Einstein. Another theory suggests that dark energy could be a form of dynamical field that varies in space and time. With the discovery of dark energy, the most likely scenario for the future of the universe is an eternal accelerated expansion. This fate is known as the Big Freeze or Big Chill, where the universe becomes increasingly colder and more diluted over time. In this scenario, the galaxies will move away from each other at ever-increasing speeds, eventually disappearing from each other's view. As time goes by, the stars will exhaust their fuel and the universe will gradually plunge into darkness. Black holes, which may be the last surviving objects, will eventually evaporate due to Hawking radiation. At the extreme limit of this future, the universe could reach a state of heat death, where all energy is evenly distributed. However, it is important to note that these predictions are based on our current understanding of physics and cosmology. New discoveries or theoretical advances could significantly alter our view of the ultimate fate of the universe. For example, if the nature of dark energy changes over time, the future of the universe could be very different. Some theoretical models propose a scenario called Big Rip, where the force of dark energy grows until it tears apart all matter. Others suggest the possibility of a big bounce, where the universe rebounds in a new Big Bang after reaching a minimum size. The idea of cosmic cycles, where the universe oscillates between expansions and contractions, is also still a subject of research. These alternative theories remind us that our understanding of the cosmos is constantly evolving and subject to revision. Despite the uncertainty about the ultimate fate of the universe, we can make more confident predictions about its near future. In the next few billion years, our Milky Way galaxy will collide and merge with the Andromeda Galaxy. This cosmic event, although dramatic, will not have a significant impact on individual star systems due to the vast distances between stars. On even longer timescales, all the galaxies in our local group will eventually merge into a single giant galaxy. Meanwhile, the accelerated expansion of the universe will push other galaxies and groups of galaxies further away from our observable horizon. In the distant future, observers in our galaxy might have no evidence for the existence of other galaxies or the Big Bang. This scenario raises fascinating questions about how cosmology would evolve in a seemingly static and isolated universe. The study of the fate of the universe is not only of scientific interest, but also has profound philosophical implications. It confronts us with questions about the meaning and purpose of existence in a cosmos that seems destined for dissolution. However, it also underscores the preciousness of our current existence and the importance of understanding and appreciating the universe we inhabit. As we continue to explore the cosmos, our theories about its fate are likely to continue to evolve and be refined. Each new discovery brings us closer to a deeper understanding of the fundamental nature of the universe and our place in it. The fate of the universe, whatever it may be, reminds us of the vastness of cosmic time and the transience of our own existence. Ultimately, studying the future of the universe connects us to the deepest mysteries of existence and reality itself. Thank you for joining us on this stellar journey. If you liked this cosmic journey, don't forget to give the video a like. Subscribe to Mysteries of the Cosmos for more space adventures. See you in the next video.